Ever try predicting something that feels like almost random? Like, will that traffic light turn red just as I get there?
Oh, yeah.
Predicting hyperchaotic systems is kind of like that.
Right.
Except instead of traffic lights, we're talking about things like the weather or financial markets, where even tiny changes can snowball into huge, huge effects.
It's true. These systems they are incredibly sensitive.
Yeah.
Imagine a butterfly flapping its wings leading to, well, not just a tornado, but a whole chain of unpredictable events. That's hyperchaos in a nutshell.
Okay, so way more intense than my morning commute.
Yeah.
And our deep dive today is tackling how researchers are using something called complex networks to make sense of all this chaos. They've laid it all out in a new research paper from Physical Review E, so we're taking you behind the scenes of the science.
And those complex networks are really the heart of this research. Think of them like a map, but instead of cities, each point represents a possible state of the system.
Okay.
These points are connected by links that show how likely it is to jump from one state to another.
So if we're sticking with the weather example, one point might be sunny day, then a link to partly cloudy, and another to thunderstorm.
Exactly. By mapping out all these possibilities, the researchers are basically creating a roadmap of the system's potential behavior. But traditional forecasting methods often stumble here because they rely on linear calculations. It's like trying to chart a hurricane's path with a straight ruler.
Yeah.
The complexity just doesn't translate well.
That's where those networks come in handy.
Yeah.
Right? They can handle the twists and turns of chaos much better.
Precisely. And what's really fascinating is that these networks aren't static.
Right.
They can actually be used to make predictions.
Wait, hold on. We can predict chaos?
Yeah.
How does that work?
It's all about analyzing the pathways through the network.
Okay.
By looking at the connections between different states and figuring out the most likely transitions, the researchers can forecast future states of the system with surprising accuracy.
So instead of just saying it's chaotic, anything could happen, they're saying, well, based on these patterns, here are the most likely scenarios.
Exactly. It's a bit like those choose-your-own-adventure books.
Oh, yeah.
But instead of choosing, we're analyzing the probabilities of each path.
Right.
And figuring out the most likely outcome.
Now, that's what I call a plot twist. But how do they even build one of these chaos-predicting networks? It sounds incredibly complex.
It does seem complicated, but the researchers break it down step by step. They start with what's called time series data, which is essentially a series of measurements taken over time. Think of it like tracking the stock market every hour or measuring wave heights during a storm.
Okay, so they're basically gathering a timeline of the chaos, right?
Right. And then they take all that data and break it down into smaller chunks, each representing a specific pattern in the system's behavior. Instead of just looking at individual data points, they're looking for recurring trends or combinations of factors that...
So instead of just wave height, they're looking at wave height combined with wind speed, maybe even water temperature, to get a more complete picture of what's happening.
You got it. And here's where it gets really interesting. They take those complex patterns and convert them into symbols. It's a way of simplifying the data while still capturing those crucial relationships between different factors.
So they're basically creating a code that represents the system's behavior.
Precisely. And that code, those symbols, become the foundation for the network. Each symbol sequence, which represents a distinct pattern, becomes a node on our map. The connections between those nodes then illustrate how likely it is for one pattern to follow another.
So we've got our chaos converted into a kind of roadmap.
Right.
But the big question is, like, does it actually work? Can we really use this network to predict what would seem to be unpredictable?
That's the million-dollar question.
Yeah.
And the research team didn't just stop at theory. They put this method to the test. Using 3 different hyperchaotic systems, known for being particularly hard to predict.
Right.
And what they found is really exciting.
Okay, lay it on me. How accurate were these chaos predictions?
They were impressively accurate,
Wow.
even when forecasting further into the future.
Okay.
In fact, this network-based method consistently outperformed other prediction methods, including, the traditional linear ones we talked about earlier.
So it's like they found a way to see the signal through all that noise.
Right.
We're not just blindly guessing anymore.
Right.
We're actually getting a glimpse into how these complex systems might behave.
Exactly. And that's what makes this research so groundbreaking.
Yeah.
It suggests that even systems once thought to be virtually unpredictable might have an underlying order we can tap into.
It's like cracking the code of chaos. This can be huge for all sorts of fields, right? I mean, imagine the possibilities if we can start applying this to things beyond these, like, physics experiments.
You're thinking along the right lines.
Yeah.
While this research focused on physical systems,
Right.
the implications extend far beyond that.
Right.
Imagine applying this to something like the stock market, where seemingly minor events can trigger these huge swings.
Or what about predicting earthquakes? They seem to strike out of nowhere, but there were probably underlying, geological patterns that could be used for prediction.
Exactly. Or think about climate change.
Yeah.
Being able to more accurately predict extreme weather events
Right.
could be invaluable for disaster preparedness and mitigation.
It seems like the potential applications are almost limitless. This could revolutionize how we understand and interact with the world around us.
It's certainly a powerful tool.
Yeah,
And like any powerful tool, it
Right.
needs to be used responsibly.
of course.
Yeah,
And carefully.
absolutely. But for now, let's just bask in the aha moment of realizing that maybe, just maybe, chaos isn't quite as chaotic as we thought.
Yeah, it's a reminder that there's always more to discover,
Right.
more to learn about the hidden patterns and connections that shape our universe.
This whole idea of predicting chaos using complex networks it's pretty mind-blowing. We've gone from brace for impact to here's what we can anticipate in just one deep dive.
It really highlights how our understanding of complex systems is evolving. We're moving beyond simply observing chaos to actually mapping its possibilities.
And making predictions based on those patterns.
It's like we're learning the language of chaos.
Yeah.
And who knows what other seemingly impossible predictions might become possible as we continue to, explore these complex systems. Maybe one day we'll be able to anticipate things we never even thought predictable.
The possibilities are certainly intriguing, but for now, I think the biggest takeaway from this research is the power of curiosity.
Yeah.
And the importance of seeking out those hidden patterns in the world around us.
Absolutely. It's a good reminder that even in the face of what seems random and unpredictable, there's often an underlying order just waiting to be discovered. So to our listeners out there, keep questioning, keep exploring, and who knows what fascinating patterns you might uncover. Until next time on The Deep Dive.